Hey everyone, I'm Sefi and I'm the CTO and co-founder of Firefly. And today I'm going to talk about lessons learned from writing thousands of lines of infrastructure as code. But before that, I'd like to explain about my company, Firefly. It's a cloud asset management solution that scans the entire cloud footprint, analyzes the infrastructure as code, and detects the discrepancy between the cloud and the IaC. The solution can generate Terraform or Pulumi code for resources that were created before manually in the cloud. We can detect drift and unexpected changes between the cloud and the IaC, and we can govern the cloud and reduce the complexity in the cloud using open policy agent, because we wrote many rules for FinOps, SecOps, and reliability. And that leads me to talk today about infrastructure as code best practices, and specifically about Pulumi best practices. And I'll walk you through the trajectory of the infrastructure as code. As you can see at this Google trend, we can see that the wide adoption of infrastructure as code, specifically when talking about Pulumi and Terraform. And I'm taking you back to before 2011, while companies held their own data centers and used technologies like Chef and Puppet to install the security patches and updates in their virtual machines. Enterprises also hired their IT departments to manage all of this operation. It was very expensive. And that's why around 2011, we started to see the migration to the cloud when companies adopted cloud services, and I call it Cloud V1. The hyperscalers, AWS, Azure, and Google Cloud launched storage and compute services. For example, AWS launched EC2 and S3 buckets, and companies adopted Ansible as the first agentless infrastructure as code tool that enabled to install everything that we needed under our EC2 with the cloud vendor's API without any agent. And in order to govern the cloud, we started to see that many companies adopted solutions like CSPM or cost optimizers to detect misconfiguration in the runtime, such as the S3 bucket that might be public accessible or users without MFA, or for FinOps point of view, we can detect GP2, EBS volumes that should be migrated to GP3 and Arise, etc. Around 2015, 2016, we started to see that many companies broke their monolith into microservices, and I call it Cloud V1.5. Because we started to see that companies adopted solutions like Kubernetes and serverless like AWS Lambda to scale their infrastructure. And we also see that companies adopted managed services like Redshift clusters, RDS, etc., to scale the architecture. The cloud vendors, the hyperscalers, also launched their own infrastructure as code tools like CloudFormation for AWS or Azure Arm for Microsoft Azure. And the community launched Helm charts for deploying everything that we need under our Kubernetes clusters, like the Kubernetes deployment with the custom resource definition, CRDs, operators, ingress or egress rules, etc. And those kind of solutions enabled us to install and to deploy everything that we needed in the cloud. For example, if now I need a Lambda function that is deployed under VPC with subnet attached, security group attached, etc., we can build all of this under YAML file and deploy with one click using the CloudFormation wizard. But around 2019, we started to see that many companies adopted more than one cloud account, more than one cloud provider. And one of the drivers for that was the acquisitions and the adoption of multi-cloud. And as you can see at this diagram, in Firefly, we made survey and we asked hundreds of DevOps teams about their cloud adoption. And we see that multi-cloud is a real thing, that many DevOps teams in the world, most of the DevOps teams in the world, adopt more than one cloud provider. And that's why we see that many companies adopted Terraform as the main unified infrastructure as code tool, because that was the first time that in the same code base, we can deploy S3 bucket and resources in Google Cloud, like BigQuery, etc. And one of the drivers for using Terraform was the immutability. It means the ability to create a group of resources and deploy in multiple environments like dev, staging, prod, etc. And that's why we see today that models are best practices. Many companies adopted Terraform models. One more thing is the shift left approach, that we can see that today we can detect misconfigurations for FinOps, for SecOps, for linter, etc. during the CI/CD, during the Terraform or Pulumi provisioning. I mean, we don't need to use CSPM or Cloudeth or other runtime scanners to detect misconfiguration in the cloud, because we can run open source tools like TFSec that was created by Aqua, or Trivi, or Kix that was created by Checkmarks, or InfraCost, or other open source tools during the CI/CD, and detect all of those checkers and all of those in a misconfiguration. And the last driver for using a unified IaC tool is disaster recovery, because we can build our immutable infrastructure and deploy everything in a dedicated region for the other environment. That's really powerful for enhancing the infrastructure and architecture. And today, I call it Cloud 2.5, because we see that companies adopted Pulumi in Crossplane, and I'll talk a lot about Pulumi in this session. But there are some interesting questions about declarative versus imperative. For example, I'm an engineer. Why should I build my infrastructure in language like Terraform, that it's a configuration or declarative language? And why shouldn't I build it in Python or Golang exactly as I deploy my application? And we also see the gap between the DevOps and R&D. If I'm an engineer and I'm in charge of my application, I need to wait to my DevOps engineer to deploy my infrastructure, and only when the DevOps engineer deploy it, I will be able to deploy my application. Why shouldn't I build my application by myself and the infrastructure by myself? And why shouldn't I decide if I want to deploy my application on Kubernetes cluster or Lambda function, or if I want to use RDS or any other services like MongoDB, for example? And last question is the cloud agnostic. It means that if in the past I used the infrastructure tools like Terraform, infrastructure as code tools like Terraform for deploying resources, and I needed storage buckets like S3, GCS, and Azure Blob Storage, there are 3 different resources. Why shouldn't I build one unified Kubernetes resource for storage and decide if I want to deploy it in Azure, Google, or AWS? And that's exactly what Crossplane does. It's a cloud agnostic solution, Kubernetes-based solution that enables to deploy CRD for storage for anything that I need, and decide if I want to deploy it in a specific cloud. It also helps to migrate one cloud to another. And in this session, I will talk about breaking our infrastructure into layers. And for now, I want to discuss about the state of IaC. That's the survey that we made in Firefly. And we asked many DevOps teams about the challenges and pains related to cloud management. And we see that knowledge, tool complexity, engineering resources, and asset visibility, that's the most challenging parts of managing infrastructure. And we understand that infrastructure as code is the only way today to manage cloud complexity, because it helps with auditing, it helps to reduce the probability for downtime or service disruption, it helps with engineering efficiency, and help to faster the troubleshooting. Now I flip the script a bit and talk more technically about do's and don'ts while implementing infrastructure as code, specifically while talking about Pulumi and Golang. But everything that I'll discuss also related to other languages like Python or C#. First thing is that we should treat our infrastructure exactly as we treat our application. The 2 main pillars are consistency and reusability. It means that we should keep our code as simple and clean as we can, and we should break it into function and into files, exactly as we do for our application. And our code should be self-explained with comments and maintained properly. And one more thing is that if we are talking about specifically if we talk specifically about Pulumi with Golang, we can break our infrastructure into layers, like networking layers and layer and services layers, and deploy each layer in Go package. And last thing is that we can use the solid principles. It means that we can use dependency injection to help the build our code with the abstractions, and it also helps to deploy unit test and to create unit tests very easily. And we should never provision any resource more than once. That's really important. And one of the ways to avoid this is to break our infrastructure into layers. And what happens if we have shared resources like the VPC? If we have multiple services that are deployed in the same VPC, we can deploy a layer of networking that will deploy the VPC, the subnets, the internet gateway, etc. And we can use the output of this layer, the Pulumi output, and to deploy dedicated layers for the services that will use the VPC ID. And that's the best practice instead of re-provisioning the same VPC again and again. And we should document our code. And I'm not talking about comments, I'm talking about version control. We should define procedures and processes for our SDLC. I mean, software development lifecycle, and not just for the application, for the infrastructure as well. And one of the ways to do that, I'll give you an example from Firefly, is when an engineer wants to change any infrastructure changes, he or she can create a dedicated side branch, deploy push the commits into this branch, and the code owner should review the changes and approve the merge to main or to master. And I personally recommend to use Pulumi Preview, to adapt GitOps as part of our SDLC, to run the Pulumi Preview while creating a branch, and to run the PulumiUP while merging to master or to main. Using that, we can detect the changes and to use the provisioning of Pulumi as part of our SDLC. And one more thing is that I recommend to use fetch rebase instead of git pull. Using that, it will help you to maintain linear git log or git graph. And it helps to understand, to review all changes. And that's a general comment that we should never save hard-coded secrets, not for our application, not for our infrastructure. And one of the ways to avoid that is to use environment variables. And you should also ignore the variable values using git ignore. And while talking specifically about Pulumi, we can use the Pulumi configuration files to save the environment-specific values. For example, if we have our code base and we deploy in production, staging, and dev, we can have 3 different configuration files and save all of the API keys, regions, the environment-specific values in this configuration file, of course, to encrypt the data. And my tip for today is that you should enable the vulnerability scanner in each Git repository, specifically while talk about infrastructure repository. And it will help you to detect misconfigurations, CVEs, vulnerabilities, outdated libraries, or hard-coded passwords and API keys. And we should use the CI/CD for infrastructure changes. Every time that we need to change the infrastructure, we should do it through the GitHub or through the Git. That we should use practices like code review to understand all changes and to review all the infrastructure changes. And we should adapt CI and CD. During the CI, we should run the unit test, and we should run open source tools like TFSec, Trivi, and InfraCost, and all of those kind of open source tools to improve our code to detect misconfiguration. And we can run also a linter for our code base. And the CD can help us to actually deploy the resources, and I personally recommend to use Pulumi Cloud. And Pulumi Cloud can also be integrated with your version control. You shouldn't bypass the IaC pipeline. Every change should be through the Git and not changing any infrastructure through the AWS console, because that's a drift, configuration drift. And drift is dangerous because it can cause downtime or service disruption. And as you can see in this example, In the left side, that's a Pulumi code that is in charge of IAM policy, and we deploy in that case a permission set for Route 53. But in the right side, somebody logged into the console manually and added Route 53 all. And that's a drift because next time we will run Pulumi preview, we'll see that one resource is going to be changed. And of course, if we will run the Pulumi app, it will revert our changes. And we should monitor infrastructure drift. And one of the ways to do that is to run continuously Pulumi preview. And if we see any infrastructure changes, we should notify into Slack, PagerDuty, or other notification systems. Or you can also use Firefly because we detect drifts out of the box with context, like who made it, when, how, etc. And we can also fix drift by aligning the code with the cloud. And my key takeaways from this talk is first that you should treat your infrastructure exactly as you treat your application. You should write your code reusable and consistent in order to maintain the code base. And you should differentiate your environments using variables, and you should never write the same code again and again. And don't forget, never save out coded secrets, nowhere, never. You can also check out the State of IaC report. That's the survey that we made in Firefly, and you can find it at gofirefly.io. And thank you very much for listening. I am Sefi Ganis, and you can find me at Sefi at gofirefly.io.